These days, it's everything retro, from old turntables, tape decks, vintage game consoles, and computers, such as the Commodore 64 that I restored in the last episode. Often overlooked is the Commodore VIC-20. At the time of its release, there were only 3 other computers with better graphics, the Atari 400, N800, and the Apple II. In the Consumer Reports magazine of 1983, only the Atari 400 competed at the same price point of $100. But the VIC-20's problem was its memory with only 3.5K of available RAM. While this can be easily upgraded today, back then you would be better off buying the Commodore 64 for the price of the extra RAM. Still, the VIC-20 helped pave the road to the future. Ah, if we could go back. Well, at least stay tuned and see if I can turn this pile of junk VIC-20 parts into something you would be proud to take home to mother. Sorry, but that lady reminds me of my grandma. I tell you, my grandma was out there. I really loved her, but 7 years old, she decided I'm going out with my life. Made a 40-year-old guy. She lied about her age, and anyways, she was, looked like kind of like in the picture there. Anyways, welcome everybody. I'm the Retro Repair Guy, and by the way, welcome and thank you for all the new subscribers. Today we're looking at the VIC-20, an often overlooked little machine that I believe paved the way to the future for a lot of other little machines. And really great unit. There's a lot of games for it, really part of nostalgia. And anyways, all the parts that I got there were parts that I pulled out from those 3 bins when I got the donations, and I did an episode on that. But anyways, that is really how I got it, all in pieces. I had no idea if it was working or anything. So let's see if we can turn it into something good. The first thing I have to do is make myself a cable to connect the 5-pin DIN socket of the motherboard to the RCA input jacks of the monitor so that I can see what shape it's in. To do this, I'm using a standard dollar store stereo cable and cut one of the ends off to replace it with a DIN plug. At first I was worried this would be a big repair as nothing was appearing on screen, but I soon realized I had the monitor set on the wrong input. To my surprise, the board turned on and seemed functional. Now that I know the board works, I'll go ahead and recap it and future-proof it. But first, I have to get this RF shield out to get access to all the components, and it's soldered pretty well to the board, so I'm trying to remove it gently without breaking anything. The board looks like it has been worked on before, but it must have been done at the factory because this shield has never been removed. The board is really dirty and the 99% alcohol isn't doing anything, so it's time to pull out the big guns and throw the board in the dishwasher. So I've said this before and I'll say it again, dishwasher at your own risk. But now that that's out of the way, do you really think the dishwasher is going to damage anything? It's just water. Yes, water and electricity don't mix. It's not plugged in. It doesn't matter because everyone asks me that. My wife's like, are you crazy? No, listen, you got to make sure it's dry. Of course, don't take it out of there, plug it in. It's going to blow up. All right, obviously, just make sure it's dry. Now, you need an air blower to blow all the water out from everywhere because underneath the chips in the motherboard where they're soldered, there's little spaces there, water gets underneath there. What you want to do is blow out the water. If you don't have a blower, okay, use a hairdryer, no heat, all right, just to blow out the water, blow it out from everywhere, let it dry for a day or two. Once it's dry, it's going to work amazing. And there's anti-corrosion stuff in the soap actually going to protect it. It's really amazing. This is about the 4th time or 5th, maybe 5, but at least 4 times that I do it on different motherboards. It works. In the old days, we used to spend $30 on these big cans called Big Bath, We used to spray it everywhere. Expensive, 30 bucks just to wash a motherboard. Insane. This works and it's free. I begin by removing the socketed chips to make sure the sockets are dry by using my blower. Upon closer inspection of the board, I noticed one of the pins in the cartridge slot had been damaged, so I attempted to repair it. I think the result is acceptable, and I tested it with a cartridge and it stayed in place. I begin removing the capacitors and replacing them with better quality ones from Nichicon. The caps are also rated for higher voltage and temperature. The video graphics chip is known to heat up a lot, so I'm redoing the soldering on that chip while I'm there, as well as the cartridge port that's probably seen years of pushing and pulling. I replaced the larger axial capacitor with one from Vishay that was also rated for higher voltage and temperature. Because there weren't too many capacitors on this board, I tested the old caps one by one, and for the skeptics, it was failure after failure after failure, and well, you get the point. Voltage losses and or resistance on every single one. For future-proofing the board, I begin by replacing the audio amplifier with one from ON Semiconductor. Another great way to future-proof is to add heat sinks to the processor, video, and other chips because the units were known to run hot. I begin by dry fitting them. I then clean the surfaces of the chips and heat sinks with some 99% alcohol. To glue them to the chips, I use double-sided thermal tape made especially for this purpose. I replaced the diode bridge with one that's a bit more resistant. Commodore used whatever parts they had on hand, and sometimes, like the capacitors, they weren't always the best. Another thing that helps in future-proofing is to add a P6KE 6.8 volt diode on the 5 volt rail. This will help by acting as an overvoltage protection for the chips, which are rated at or about 7 volts. We can thank Jan Beta for this information. I already added some heat shrink tubing to the leg of the diode, but as an extra precaution, I'm covering it with a piece of high-quality electrical tape. And here's the completed board, recapped, clean, future-proofed, and ready for a new life. So when it comes to future-proofing, a couple of things. First of all, Commodore used whatever they had on hand at the time, so it wasn't always the greatest parts. And that's why there's no consistencies in the voltage as well. Some were 35, some were 16, some were 25 volts. I replaced them all with 50 volts and a higher rating of 105 degrees as opposed to the standard 85. Now it's important to note also that you really want to change those capacitors. As you saw from the video, there's a lot of ESR, high resistance, as well as high voltage losses in all of these capacitors. But that's not the point. The point is, even if it's working, even if you're not getting voltage losses, even if the unit turns on, you want to change that. To me, it's the same thing as my roof is 40 years old, everything is curling up. I'm not going to wait for a leak. I know it's due. I'm going to do some preventative maintenance. So same principle here. You're going to prevent something bigger from happening or a damage. These are, very cheap components. They're like a couple of cents each, 50 cents, 25 cents, whatever. It's really worth changing, especially when you're in there. You're going to be, trying to future-proof it and fix it. Another cool little trick is the 6.8 volt diode on the 5 volt rail. Now this is not my idea. This is Jan Beta from his channel. So shout out to his channel. I don't know him, but I think when we fix stuff, we're on the same wavelength. He changes the capacitors, really tries to future-proof the machine. So the trick here is the chips are rated at 7 volts. And there's a 5 volt rail, so if ever there's a spike, this will basically act like a fuse and blow this before blowing your chips. So a cool little idea. I integrated into this. And if you have more ideas, send them our way. But I changed the diode bridge with a more sturdier one. And of course, all the capacitors, put some heat sinks, put this on. Should last a little while. Well, I'm happy with the results. Yes, I think I did a good job. I really did a good job, though. Seriously, this was a pile of garbage, and it came from the donation bins. But I don't even know why it was open, what the story was, if they tried to fix it. But hey, it's working. It's great. I got a bunch of games for it. I'm a little sad I couldn't get Donkey Kong to work because I really want to play Donkey Kong. I want to show my daughter. But that being said, it's fantastic. I'm very happy. And there's still games being made for the VIC-20 and the Commodore 64. You can add the memory cartridge. You can do a lot with it. And so anyways, beautiful, beautiful little machine. Let me know if you want to see more of these being fixed, because I got 3 bins full that I received. Otherwise, I got, and I point there because you don't want to see what's there. There's a lot of stuff there. And it's I go to the thrift store a lot also during the week. Shh, don't tell my wife. But I'm always picking up stuff. So look, do you want to see more Commodore stuff? Do you want to see different things? You have something specific in mind? Let me know. I'll try to find it. And thank you so much for watching. Don't forget to subscribe if you want to see more of these things. And I'll see you guys next week. Bye-bye.